All right, let's talk about a new kind of invisible warfare. A battlefield where things are moving so fast, I'm talking hypersonic fast, that human decisions are basically useless. A place where all the old rules of engagement just don't apply anymore.
So let's just jump right in because this really gets to the heart of a terrifying new problem. In this explainer, we're going to break down a battle space where, according to our source material, the old ways of doing things, secret codes, encrypted software, are becoming completely and utterly obsolete.
So to really get what's going on here, we have to start with a huge weakness in our modern air defense systems. I mean, a flaw that basically kicks the door wide open for a whole different kind of weapon.
And here it is. This is the core problem, laid out right here. The way we normally tell friendly planes from enemy planes is called IFF, Identification Friend or Foe. It all relies on secret encrypted radio signals. But in an age where quantum computing is a reality, well, that whole system is reportedly broken.
Now this slide really puts it all into perspective, doesn't it? On the left, you've got the old way, encrypted radio codes, keys that rotate, all based on trusting your software. But on the right, you've got the threat. The source alleges that U.S. quantum computers can just tear through that military-grade encryption in milliseconds. Think about that. That means they could pretend to be a friendly aircraft, and you'd have no way of knowing until it's too late.
So, if you can't trust software anymore, what's left to trust? Well, according to this analysis, the Russians decided to look for a pretty radical solution. One that isn't based on code, but on the cold, hard, unchangeable laws of physics.
And this right here is the key. Instead of listening for a secret password that can be stolen or faked, this Koopal system supposedly reads the physical essence of the object itself. It's like an atomic fingerprint. Every single object vibrates in its own unique way based on what it's made of and how it's built. You just can't fake that.
This is a perfect way to picture it. Different things are made of different stuff, right? So they'll all have a unique signature. A Russian Su-57 fighter with its titanium and composite frame is going to have a totally different vibration than, say, a super-dense tungsten rod dropped from orbit. And that's going to be completely different from the weird exotic bismuth magnesium material allegedly used in a U.S. Tic Tac drone.
Okay, so that leads to the next big question. How? How in the world does this system actually read that physical fingerprint from miles and miles away? Well, the answer, according to the source, gets into some pretty controversial physics.
So the source material here suggests a technology that goes way beyond normal radar. See, radar waves can be jammed or blocked, but these theoretical scalar waves, they're described as moving through the very fabric of space itself. In theory, that would let them pass right through an object and read its internal atomic structure without anything getting in the way.
And the process itself is brutally simple. First, the system scans the sky with these low-power waves. Second, it reads the unique signature of anything that flies through that space. And third, it compares that signature to a database of all known friendly aircraft. Scan, read, compare. That's it.
All right, so what happens when the system finds something it doesn't recognize? In this new world of hypersonic warfare, there's just no time to call a committee meeting. The answer has to be fast and it has to be fully automated.
The system apparently operates on what the source calls a whitelist protocol, and it is ruthless. If an object's physical signature is not on the pre-approved list of friendlies, it's automatically, instantly classified as a threat. No questions asked.
250 milliseconds, a quarter of a second. That's about how fast a top-tier fighter pilot can react. But when you're up against a threat moving at over 2 miles per second, that's just catastrophically slow. In this kind of scenario, the argument is that the decision to fire can't be made by a human. It has to be the machine.
So the very instant an unknown signature is confirmed, the system unleashes its countermeasure. The same transmitters that were just scanning on low power get cranked up to an absolutely massive gigawatt-level burst of energy.
And here's where it gets wild. According to the theory, where these two invisible beams of energy cross, they interfere with each other and explode back into conventional energy. They create this enormous, localized ball of superheated plasma, just appearing out of thin air. Anything hitting this invisible wall at hypersonic speeds is, well, it's instantly vaporized.
Now this brings us to what might be the most incredible part of this whole technological chess match. It's what the source calls the final, tactical irony of this new arms race.
So here's the twist. The source claims some advanced U.S. craft, like the Tic Tac, use their own self-generated plasma bubble for stealth, and that makes them invisible to radar, which is a huge advantage. or it was. Because in this new game, that amazing strength becomes a fatal weakness. Get this, that very same plasma that makes the craft invisible to radar, it apparently creates a massive, impossible-to-miss signature for the Russian Scalar system. The source argues the Koopal doesn't even have to bother reading the metal of the craft, it just looks for a fast-moving bubble of plasma. It's like painting a giant glowing bullseye on yourself, making you the easiest target in the sky.
If this theory holds any water, it just completely changes the entire paradigm of modern war. It suggests we're moving away from a fight over information and code and into a battle of fundamental physics. So I'll leave you with this thought to chew on. What happens when the very materials you use to build your ultimate stealth weapon become the exact signature that targets it for instant destruction?